All right, 2.3 tomato plants, box plot. A box plot can also be used to represent the distribution of numerical data. So again, we're talking about numerical data here, right? This would be, you would never use a box plot to represent categorical data. You could use a histogram to represent categorical data, right? You could have each category be like if we were talking about brands of chips like Doritos, Takis, Lay's, Pringles. You could have different bars, and each one would be the frequency of each category. But for this graph, the box plot, you need it to be numerical data. It doesn't make sense with categorical because we talk about minimum and maximums. And when we talk about categories, it doesn't matter what's greater or less than. When we talk about numerical values, you can compare the two numbers, what's more, what's less. So using the same data as the previous activity, we are going to find the median. So there should be some review, again, from previous years of math, and I'm going to erase all this stuff I drew here because it's going to make it very complicated to understand. Or at least my method for finding the median is way easier. I can cross stuff out. So if you remember, what does that word median mean? What does it kind of sound like? Well, median is just the middle. So the way I like to find the middle is I cross off one from each end until I get to where the middle is. So I'm going to cross out my first, my last, second, second to last, third, third to last. I'm going to continue to do that. All right, and you can see we have an even number of numbers. So this is going to actually be a little problematic now, because when I try and get to that middle, we're going to find that we don't actually really have a middle. Well, we do, but we technically have two numbers. All right, so my two numbers here, 70 and 72. So if I want to find the middle between those two numbers, there's a couple ways you can think about it. Some of you might just be able to see, oh, if I've got 70 and 72, the number in the middle of those two has got to be 71. Another way you think of it is to find the average of the two numbers. I'm going to add 70 and 72, and then I'm going to divide by 2. All right, 70 plus 72 is 142. And if you put that into your calculator, you'll get 71. So 71 would be the number that's really in the middle of this data set. Bring it 72. Okay, what does the median represent for this data? For these data? That's sort of a weird way of saying it. For this data, I would say it represents the middle of the data set. Find the median of at least 15 values to split the data into the first and second quarters. This value is called the first quartile. Add this value to the table under Q1. What does this value mean in this situation? So I'm going to look at my first 15. So that's in this first half up here. Now I'm going to use the same method. This time I'm going to draw like an X in the opposite direction, a slash in the opposite direction. And so first, last. And I'm doing this very quickly. You may want to do it a little bit slower when you do it. So I can see 62 is right in the middle of this data set. So what does 62 represent? Well, if this is the middle of the data set, this would be the middle of the first half of the data. Really, they call it the first quartile. The first quarter would be a valid way to describe it. Quartile really means the first quarter. Now they want us to do the same thing for the bottom half. Find the third quartile, Q3. So I'm going to do the same thing. I'm going to make a slash in the opposite direction now. We get 78. And you'll notice that the only reason I'm able to do this method is because all my numbers are in order. If they were not in order, I could not do this. So we're sort of lucky that they gave us the numbers in order. So 78 will be my Q3. All right, so based on what we said for number 2, now you try and write what you think the third quartile represents. All right, so hopefully you feel as though the first quartile or the third quartile, the third quartile is the middle of the second half of the data set. All right, now they also want the min and max. So if I look at my data set here, what would my min be? What would my max be? Well, your minimum would be 47 and your max would be 90. All right, so this is known as a 5-number summary. I'll write the word number so that doesn't confuse people. Hashtag can also mean, I guess. The minimum, first quartile, median, third quartile, and maximum. Okay, so now we're gonna make a box plot. So what you wanna do is everywhere you see one of these 5 numbers, you wanna make a vertical line. So 47 is my min, so I'm gonna put 47, that's like right about here. 62 is my Q1. 72 is my median. Q3 is 78. And the maximum is 90. Okay. Here. Yes. All right. Great. So now what we do, if we look at our do now, this is what a box plot is supposed to look like. So this first line, that's Q1. I'm sorry, not Q1. Wrong. That first line here, that would be our min. And Q1, our median. Q3, and then our max. So what we can do with Q1, median, and Q3 is we make our own little box here. This is known as the IQR, the interquartile range. All right, that makes sense. We're between the 2 quartiles, inter meaning between, so interquartile range is right there. And then for the min and max, we just draw a line like that. Okay, that is all for today. Have a great day.